Okay, 8.6 is exponential decay, which means lessening, how fast it becomes less. That's what decay is. Let me remind you from the previous unit that exponential growth is y is equal to c times 1 plus, let's make a different color here, plus r times, well, raised to the t or the time. Exponential decay is different because it's slightly different, and you need to recognize that y is equal to c parentheses 1 minus r. Minus r, and that's the big difference between decay and growth. Now, the r always has to be more than 0. Oh, I should write that number down. 0. But it has to be less than 1. And that would be decay, exponential decay. Let me write up some examples right now for you. Let's hope it's easy. It's exactly like the previous unit, except we're doing negatives in this case, and we need to recognize the difference between growth and decay. Okay, so here's an example problem. Let's say I buy a computer, a bike, I don't know what it could be, but you paid 1,800 euros. It's a real expensive computer, by the way. And it depreciates. The word depreciate means it loses value. It loses value is what depreciate means, at a rate of 29% each year. Let me put a little line across here so we don't confuse these right here. Okay, so I'm going to use my exponential decay formula in order to write this down. I'm going to use purple right now. And so I'm going to go y is equal to, well, what was my initial, how much was it worth initially? And I guess initially it's worth 1,800 euros, or 1,800 euros is another way of saying it, times 1 minus, because we're doing depreciation, because depreciation means less. 29%, for 29%, I got to move my decimal from here 2 places, which means 0.29. And the t value is each year. And let's say I've owned a computer for 5 years. I forgot to put up here 5 years. I want to know what my computer is going to be worth after 5 years. So the way you write this model down, if they were to ask you to write the model for this, the model would look like this. Y is equal to 1,800 times 1 minus 0.29 is 0.71 p. And if you want to know it for 5 years, you just have to put the 5 in here. And what you do then is you go 0.71 raised to the 5th year. And that's going to give me 0.1804 bunch of numbers, right? Times 1,800, which gives me, after 5 years, my computer will only be worth 324 euros and 76 cents of a euro. So that's a kind of a bad investment, because you keep on losing a lot of money when you buy a real expensive computer. And in 5 years, the reality is that you probably get a better computer or whatever. So